going to go over lesson 35 on this video, and from the feedback I got last time, most of you liked when I did this because you got through it quicker. I'm going to be going through these problems fairly quick to keep the video a little shorter. I'll see what I can do about getting this posted to YouTube and getting a link put in your e-backpacks with the, we'll just have to see how that works. I'll try. So don't get ticked off if you can if I don't have it done. But anyway, we talked the other day about factoring. Well, actually, we found the greatest common factor. We haven't talked about factoring the greatest common factor. That's what we're doing today. But if we looked at this problem and these two parts, real quick review, the greatest common factor of this problem would be 2, because we can take a 2 out of each term. And then there's an a in each term, and there's at least one, so the greatest common factor is 2a. Now, whenever we see this part with factoring in front of it, factor that greatest common factor. Factoring that out means we're going to divide out the greatest common factor, which is 2a, out of each term. We're going to divide the greatest common factor out of each term. So if I put 2ax over 2a, the 2's would cancel, the a's would cancel, so I'm simply left with x. And then on the next part, I have the plus, the 2's would cancel, the a's would cancel, I'm left with c. That is going to go inside parentheses. We're doing the reverse of the distributive property when we factor the greatest common factor. We're starting with something that's already been distributed through, and we're going backwards and taking that out instead. And so we end up with this. When we factor the greatest common factor, that's what it would look like. That would be your answer. Please do not freak out, as many of you might do, because this doesn't come to you right away. Just watch these examples. I'm going to do about 3 or 4 more of these examples. And again, hopefully you can get a chance to watch this later. Factor the greatest common factor out of these 3 terms. Let's go through our smallest a. We have a cubed, a squared, a to the 4th. Our smallest is a squared. Our common factor for x's will just be x because of our second term has just 1 x in it. And then our value for m that we're going to factor is m squared. That's our greatest common factor. And by the time we got done with that lesson the other day, most of you had this down. Now we're going to divide those out of each term. And I'm not expecting you to do this, but I'm going to do it for one more example just to show you how this works. I'm going to put each of these terms over the greatest common factor, and then we're going to essentially reduce. So if I take a cubed and take away 2 of those a cubes, or 2 of those a's away from a cubed, that would leave me with 1 left over. Then I take this 1x on bottom and cancel with 1 on top, would leave me with 1x on top. And then I wanted to factor m squared, so that should have been an m squared. If I factor m squared and m squared, that just goes to 1. So my first term that I factor out would have an a and an x left over in it. Plus, now we look at the next one. I had an a squared on top. That's going to cancel with the a squared on bottom. The x on top cancels with the 1x on bottom. Now I have m squared on bottom, so that's going to cancel 2 of the 3, so I'd still have an m left over. That's all that's left in that term, so that's going to be m. Then I have a minus sign, and I'm going to cancel out here. I have an a to the 2nd on bottom, so that one cancels with 2 of the 4 on top, so I'd still have an a squared on top. My 1x on bottom would cancel with 1 of the 3 on top, so that would leave me with x squared. And then my m squared and my m squared cancel, so there's what I have left, a squared, x squared. If you took and redistributed this greatest common factor through, and I'm not saying to do this, but if you did do this, that would be a way of checking it. and seeing if you got what we started with up here. That's factoring the greatest common factor. Here's our greatest common factor, and here's what's left when we factor that out or divide that out of each term. Okay, this next example I'm going to go a little bit quicker with. Our common denominator, we do have to look at the coefficient value. So I have a coefficient each term, and the common factor there is 2. My smallest a is a squared, my smallest b is b, and then my smallest z is z cubed. So that's what I'm going to divide out of each term. So I start here. 4 divided by the 2 is 2. A cubed divided by the a squared leaves me with 1a left over. B to the 4th divided by my b is b to the 3rd. My z to the 3rd divided by my z to the 3rd is 1. So I don't have to show that. So this time I'm going to do it now, but I didn't write down this 2a squared b z to the cubed underneath it. I just did that mentally from point to point. So you don't have to show this if you can see what it is you're canceling. Okay? Then I'm going to do the same thing with the other term. I'm going to factor out a 2 out of my 2. Well, I need my plus sign there. I forgot that. I need to factor 2 out of 2. 2 out of 2 is 1. 2 divided by 2 is 2. 1. Then I have a squared over the a squared. That has a value of 1. 1 times 1 is 1, so I'm not going to put that second 1 in there. The b over b, it goes to 1. So that would be 1 times 1 times 1. I'm just going to put 1 in there once. Then I have my z to the 4th divided by z to the 3rd. That's z. I have 1z left over. So your answer would be 1z. It really looks better if you don't have the 1 in front of there, but I would accept it. But that would be your answer. That's your greatest common factor. Again, you could distribute this 2a squared bz cubed through to see if that gave you the answer you had to start with. I think this is the last one I'm going to go over, even if it's not the last example I have, but I believe it is. So looking here, we have 3 different terms. My greatest common factor for my coefficients, 2. Then my smallest a, I have to wait for this stuff on the left to stop moving, catch up with me. Okay, so then I have 2, then a squared is my smallest, and x squared is my smallest. So I'm going to divide that out of each term. Starting here, 6 divided by 2 is 3. A squared divided by a squared is 1. X squared divided by x squared is 1. 3 times 1 times 1 is just 3. So I don't have to put anything else with that one. Then I have 2 divided by 2 is 1. A cubed divided by the a squared is a. X cubed divided by x squared is x. There's that. Then I go plus. 4 divided by 2 on this last term is 2. Then I have a to the 4th divided by a to the 2nd would leave me 2a's left, or a squared. And x cubed on this last term divided by x squared would leave you with 1x. Again, we'll review this tomorrow, so don't panic if it seems a little bit foreign to you. The next type of problem that we're going to be looking at is something like this. My question, if I was here, I'd want to hear what you had to say, and we'd argue and discuss it and stuff, is this question of, is x plus 4 over 4 equal to x plus 1? I sometimes get some trues and I sometimes get some falses, and here's what is taking place. And again, this is something we can talk about more when I'm there, but what a lot of students want to do is they see this and they see the 4 on top and the 4 on bottom, and they reduce them. The problem with that, and that would indeed look like x plus 1, the problem with that is that you're dividing, which is reducing is dividing, across addition. And dividing and addition are not inverse operations. So we cannot do that. when we have a plus sign in a fraction or a minus sign in a fraction like we do here, we have to think of this entire numerator as being one specific value. We can't just take a part of that out. We have to have that whole piece grouped if we're going to cancel with something on bottom. Okay, so if it has to be the exact same thing on top with something on bottom. We can't just take a part of it out. Now, we get into this, and this ends up being one of the problems that a lot of students have difficulties with, but I'm not exactly sure why. Here we have 4 times this quantity of a minus 3. Since 4 is being multiplied times this quantity of a plus 3, then I can indeed divide it because they're inverse operations. So here I end up with 4 over 4 being 1 and 1. If I take 1 and distribute that back through, I simply end up with a minus 3 over 1, so my answer would be a minus 3. Here, if I think of this bottom piece, this x minus 2 on bottom, as being one value by putting it together in parentheses, then it looks exactly like this top part that has x minus 2. No matter what the value of x would be, if I plug that in for the top and the bottom, they'd be the same value. If x was 5, 5 minus 2 on top would be 3 there, 5 minus 2 is 3 there, and these two would cancel. So we can cancel quantities as long as the quantity on top is exactly the same as the quantity on bottom. So in this situation, those two go to 1, you'd just be left with 3. And we're looking at about 12 minutes right now, so I'm going to speed along, try to get this finished up. Here's where the interesting thing happens. I just went over the fact that we can't take 3 over 3 and divide it, or reduce it. However, we did earlier in this lesson discuss factoring the greatest common factor. So if we look simply at this part on top, just a minute, let me get this. If we look just at the 3p plus 3, the greatest common factor in that is 3, which is some ways coincidental to the fact that the numerator or the denominator is 3, but don't worry about that. I'm just looking at the 3p plus 3, and my greatest common factor is 3. So I'm going to factor out the 3 out of that equation, or out of that part, and that would leave me with, after we just went over this, 3p divided by 3, just factoring the 3 out would leave us with a p, and then the plus sign, and then 3 over 3 is 1. If you distributed 3 back through, it would look exactly like this part. Okay? And then on bottom, I have a 3. Now this looks like the situation we had earlier on the 2 screens before, where I have 3 times this quantity, so I can now divide or reduce those down to 1 and 1. And so your answer would be p plus 1. One more here. Our greatest common factor for 3x and 9x squared would be 3x. I can take a 3x out of each of those terms. 3x here divided by our greatest common factor of 3x would be 1. Minus. Then 9 divided by 3 is 3. X squared divided by x is x. So there's my quantity. Again, distribute your 3x through if you don't think it's right, and see if it gives you what you had here. Then that's over 3x. Now the implied operation between 3 and the x and the quantity is multiplication. So I can reduce the 3 and the 3 and the x, and that all goes to 1. So all that's 1, so your answer to that would be 1 minus 3x. If you show it with parentheses, that's fine, or it could be without at this point since we got rid of that other stuff. So there you go. The assignment's going to be on the assignment board to the right in the front of the room, and the sub will have that also. And I'm finishing up just shy of 15 minutes, so hopefully that gives you enough time to get started on this.